Let's solve LeetCode question number 73, set matrix zeros. Given an m by n integer matrix, if an element is 0, we need to set its entire row and column to zeros. We also must do it in place so the function will not return anything. So let's say this is the matrix that we're given. There are two zeros here, so we'd set the entire row and column of each 0 to be all zeros. And this is going to be the new modified matrix. Now, the most naive way to approach this is to just traverse through the matrix and set the row and column zeros as we're going through the matrix. So here we found a 0, so let's go ahead and set the entire row and column to zeros, and now we can continue looking for the next 0. The problem though is that when we move on to the next element, we find that this is also a 0, so we'd set this entire row and column to zeros, but this is wrong. So the problem is that this cell wasn't originally a 0. So if we set the zeros as we're traversing the same matrix, we end up incorrectly setting a bunch of rows and columns to 0. So one way we could solve this is to use a copy of the matrix. We'll traverse the copy instead of the original, and when we hit a 0, we'll zero out the rows and columns of the original matrix. Then we'll go back to traversing the copy, and this way, we don't confuse the original zeros with the ones that we set later on. This approach works, but since we had to copy the entire matrix, this runs in O of m times n space. But if you think about it, we don't actually need to copy the entire matrix. All we need is just one indicator per row and per column to indicate whether that row or column needs to be zeroed out. So an improved version would only use two arrays. The one on the left will indicate whether each row needs to be zeroed, and the one on the top will indicate whether each column needs to be zeroed. So let's traverse the array the same way we did before, but now when we hit a 0, we'll update the corresponding indicators for this row and column. And this can be a Boolean value like true. Then we'll continue traversing. This row has no zeros, so we'll move on. And now we've hit another 0. So again, let's update the indicators that correspond to this row and column. Then once we've finished traversing the entire matrix, we can look at our indicators and zero out the appropriate rows and columns. This approach only required an array of length m plus an array of length n, so this runs in O of m plus n space, which is a major improvement. Now we can actually take this one step further and solve this using constant space. And we're going to do this by using the first row and first column of the matrix itself as the indicator arrays. So the first change I'll make is, instead of using true, I'll use a 0 as my indicator. And now we're going to use the first element of each row and column to indicate whether that row or column needs to be zeroed out. So the first row and first column serve as the indicator arrays. And we can do this because if a row or column needs to be zeroed out, then the first element of that row or column will end up being a 0 anyway. So we may as well use that as our indicator. Now you'll notice that there's one small problem here, which is that the very first cell is part of the first row and first column. That makes this cell ambiguous because if it's a 0, we don't know whether it's referring to the first row or first column. So we actually won't use this cell at all, and instead we'll create two new booleans, one as the indicator for the first row and another as the indicator for the first column. Since we'll only ever need two extra variables no matter what the size of the matrix is, this runs in constant space. And as you'll see later in the code, we'll only need to iterate through the entire matrix twice, once to set all the indicators, and another to set the matrix values themselves to 0. So this runs in O of m times n time. Now let's look at the code and solve this in Python. Let's use this matrix, which is a 2D list with 5 rows and 4 elements per row. And here are all the zeros. I'm going to indicate the index of each row and column like this. I'm also going to draw this divider here, just as a reminder that the first row and column are being used as indicators, and so they're actually going to be processed separately from the inner matrix. We'll first create our two booleans, first row and first col, and initialize them to false. Remember, these will be used as indicators for only the first row and first column. Let's also grab the number of rows and columns and store them in variables. Rows will be the length of the matrix. Since there are 5 inner lists inside of the outer list, rows will equal 5. Cols will be the length of the first inner list in the matrix, and since each inner list contains 4 elements, cols will equal 4. Now the first thing we'll do is figure out if there are any zeros in the first row or first column, and set the indicators accordingly. Now you could write an ordinary loop and loop through the first row and column to find any zeros, But there's a very nice declarative way to do this in Python that I wanted to show. So we can use the Python in operator to check if there is a 0 in the first list of the matrix. This will return true if there is a 0 and false if not. And as we can see, there is a 0 in the first row, so first row will be set to true. For the first column, it's a little wordier, but let's break this down. For each row in the matrix, so that's each inner list, we're going to check whether the first element of that row is equal to 0. So in other words, we're checking the first column for zeros. Now when we combine this with the built-in any function, what this means is, if this condition is true for any of the rows in the matrix, then this function will return true. And if this condition is false for all the rows, then this will return false. So right now, we can see that there is a 0 in the first column, so first call will be set to true. Now that we've processed the first row and column, we'll start iterating over the rest of the matrix to find out where the rest of the zeros are. We'll use the variable r to iterate over the rows, and c to iterate over the columns. And these will both start at index 1 because we already processed the first row and column. Then we'll check if the element at row r and column c is equal to 0. If it is a 0, then we'll have to set the indicators for that row and column to 0. But since the current element, 9, is not a 0, we'll just move on to the next element at column 2. Now this element is a 0, so let's set our indicators. First let's set the row indicator, which is going to be the element at index 0 of row r. In other words, we'll set the first element of this row to be 0, to indicate that this row must be zeroed out. Next, let's set the element at index c of row 0 to 0. By doing this, we've set the first element of this column to 0 to indicate that this column must be zeroed out. Now, in this example, the column indicator was already a 0, so it didn't change. Now, moving on to the last element of this row, 6 is not equal to 0, so we've now finished the inner loop, and we can move on to the next iteration of the outer loop, where r equals 2. Again, c will start at 1, and the element at index r and c is 7. This is not 0, so let's look at the next element, which is also not 0. And neither is the last element of this row, so we'll just move on to the next row. Again, the first element is not a 0, and neither is the second one. But at column 3, we finally find another 0. So again, let's set the first element of this row to be 0, and then let's set the first element of this column to be 0 as well. And finally, for the last row, we can already see that there are no zeros, so we won't do anything for this row. We're now done setting all the indicator zeros, so now let's actually set the matrix values to zeros. Again, we'll use r and c and start at index 1. Then for each element, we'll check if its row indicator or column indicator is 0. If either of them are, then that means that we need to zero out that element. Right now, you can see that the first element of this row is 0, so let's set this element to 0 as well. Next, the first elements of both this row and column are 0, so we'll set this to 0 as well. And the same is true for this third element. For the next row, neither the row indicator nor the column indicator is a 0, so we're not going to set this element to 0. Next, the row indicator is not 0, but the column indicator is, so this becomes a 0. And it's the same thing for the next element. Moving on, this row has an indicator of 0, so we already know that this entire row needs to be zeroed out. So let's go ahead and set every element in this row to 0. And now in the last row, neither indicators are 0 for this element, but the column indicator is 0 for this one, and also the last one. Now we're done processing the inner array, and all that's left to do is set the zeros in the first row and column. So if our first row indicator is true, which it is, then that means we need to zero out the first row. And this is another cool way to do it in Python. And we're going to set the first row of the matrix to be a list of 4 zeros, because there are 4 columns. So now the first row will be filled with zeros. And then let's do the same thing with the first column. If first call is true, which again it is, we'll need to zero out the entire first column. And for this, there's not really a great one-liner in Python, so let's just iterate over each row. The row variable will be each inner list, and so for each row, we're going to set the first element to 0. So by setting the first element of each row to 0, we've now set the entire first column to 0. And that's it. You can see where all the original zeros are in red, and you can verify that all the rows and columns of the original zeros have been set to zeros in purple. And since we've directly modified the original matrix, there's nothing to return, and we're done.